Good afternoon. My name is Marie-Hélène Nieb, and I welcome you to the group exhibit, Hydrogen, Fuel Cell and Batteries. We have the opportunity today to discuss power to gas, supply concepts for green hydrogen. Please help me welcome from DBI Gas, the Managing Director, Dr. Professor Hartmut Krause. Thank you for joining us.
Nice to meet you.
Before we get into the great concepts of supplies, I'd like you to just give us an introduction to about DBI Gas, please.
Yeah, DBI Gas and Environmental Technology in English is a small engineering and research company in East Germany. It consists of two units. The main unit is an engineering unit, which makes engineering for the gas industry, especially for gas net operators. And we have a daughter company, which is a research company, non-profit research company, which is doing applied research for the gas industry. About the complete chain, value-added chain of gas supply, from the production of natural gas up to the usage of natural gas via the gas transport in Germany and also in Europe.
So if we get into our topic at hand here, power to gas, concepts of supplies, what in your mind are the feasible concepts of supply?
Yeah, there are a little bit struggling between two concepts. I mean, one concept is maybe very well known, is to produce hydrogen from renewable power, wind or PV, fluctuating renewable power, and put it into the natural gas grid, where you can use it very broad in different appliances together with natural gas. The very advantage of this concept is to use an existing infrastructure from natural gas, which consists of a large number of kilometers pipeline. In Germany, we have more than 500,000 kilometers natural gas pipeline. We have a large number of underground gas storages, so you can bring the hydrogen from renewable electricity to a large number of customers. In Germany, it's nearly 14 million customers, and when we look to Europe, we have about 100 million customers which are connecting to the natural gas grid.
So would you say the main advantage of just introducing the hydrogen directly to an existing infrastructure is only economical, or is there more advantage to that as well?
There's a little bit more advantage because the history of natural gas means that the production of natural gas is normally very smooth and on the same level, but the usage of natural gas is also fluctuating between summer and winter time. I think it's normal, you understand that. So we have a difference between summertime and wintertime about 1 to 20. So that means that you have to put a buffer in between the production and the supply, the usage, to store large amounts of energy, of natural gas. So, and this advantage is also good for hydrogen, and to use that is using an existing, very expensive infrastructure for the purpose of storing energy from fluctuating production sites to fluctuating, in another way, fluctuating usage of gas.
Is there limitation to this concept, though? Are there limitation to the existing system? Like, how much can we actually introduce? How much hydrogen can we introduce in the existing natural gas system?
This is one disadvantage, maybe. The natural gas network, or the customers of natural gas network, gas grids, are expecting very high level of gas quality. And if you are injecting hydrogen into that natural gas, the heating, the calorific value goes a little bit down. So that means the percentage of hydrogen what you can add to the natural gas is limited. Now we have a limitation between 2 or 10%. It depends on the customers which are belonging to that part of the grid. And so it seems at first that it is very small amount of hydrogen what you can put in, but when you look to the total amount of transported natural gas, maybe in Germany, this is an amount of about 1,000 terawatt hours per year, and so 2% are 20 terawatt hour per year. That's a very huge amount of energy. So this is a limitation, yes, but this limitation is not strong.
It's not really, it's a limitation, but not something that we're going to hit soon anyway.
Yes, yes.
And before I go with my next question, I just want to remind everybody this is a public forum, so you are welcome to ask any question. Just raise your hand, I'll come down with the microphone. So this is the first concept of supply of hydrogen, or one that you believe is suitable and it makes a lot of sense. What would be the second way that we could supply hydrogen?
Yeah, this first concept I explained now is is a concept which is easily to erect or to start on. Another concept is to produce hydrogen and put it directly in a separate to supply customers with 100% hydrogen. This is a second way, but the problem is there is no large infrastructure for that way. In Germany, we have two regions or two locations where hydrogen is distributed by pipelines. This is in near Cologne and Rhine area, lower Rhine area. There we have 200 kilometers of hydrogen grid network.
And it's an underground network?
It's an underground.
Just like natural gas, but it's hydrogen?
Yes. It is used for the chemical industry in that region. And the second location is in East Germany, near Leipzig-Halle, where there's also a large chemical industry area. And also there we have about 150 kilometers of hydrogen pipeline grid. And this could be a seed for introducing renewable energies by electrolyzers to hydrogen and inject it to this fossil hydrogen supply. And
so DBI Gas is working directly with this region to expand or to just learn more about this existing hydrogen network?
First of all, to learn more, to integrate renewables into this pipeline grid.
What do you mean by integrating renewable?
Integrating or otherwise taking over electricity from renewables, producing hydrogen by large electrolyzers. This is the new way. Injecting in the existing natural hydrogen pipeline grid, and on the other side, in that area, this is a special advantage of this area, Middle Germany. We can use there an underground gas storage to store large amounts of hydrogen. This is very near to the existing hydrogen pipeline grid, and these two parts are the new where we want to learn more about in introduction hydrogen in the fossil supply chain. And the other side is if we increase the production of hydrogen by renewables, it is interesting to find new and more customers for that hydrogen. And customers are not only chemical industry, but also the urban supply for energy, maybe in fuel cells, in stationary fuel cells. And on the other side, to introduce these hydrogen into mobility concepts, supplying filling stations at the highway, maybe, or at...
So in the Cologne area, you could foresee putting refueling station for fleet vehicle or something like that. You're basically thinking of using those regions that have an existing hydrogen network as a development base or a playing field in some way.
This is the right word, a playing field, to use modern and new technologies. And the idea is to enlarge or scale up all these technologies to become beneficiary, not only for the customers, but also not only for the producer, but also for the
users.
Customers. Yeah, and to learn in a very easy way these technologies, to bringing these into the market.
So you propose to us two different concepts. One is to use the hydrogen injected into the existing natural gas grid. The other one is to provide pure hydrogen through a network like in Cologne or through transportation. Out of those two concepts, which one would you say is the key to get started, or that we will use first, that will have more of a place?
Yeah, the first and the best or easily concept is to inject it into the national gas grid, natural gas grid. And if we look to Germany, we have meanwhile 4 demonstration plants there. The first one started operation in 2013 in Falkenhagen. Maybe someone of you are knowing that plant. There is an alkaline electrolyzer which is producing nearly 300 cubic meter hydrogen per hour, and injected this in a gas transportation pipeline. So
and you were telling me earlier today when we had our pre-interview that this project was successful but had limitation from regulation side.
Yeah.
What were those hurdles?
Yeah, the hurdles are a little bit complicated because in Germany there is a regulated system to introduce renewables in the energy supply, and but the hydrogen production from renewables are not really introduced in this taxation or regulation system. So the problem is that the current which is used for production of hydrogen is taxed by different taxes. So the costs or the price for the produced hydrogen is quite high, and so the competition to the fossil fuels is very complicated and not easy.
It's difficult because they get taxed on the electricity, and even though it's a renewable energy, but the current regulation doesn't really allow for that. Is there any work done currently in the EU towards changing that regulations?
Yes, different initiatives are starting to discuss it. Last year we have a novellation of the Renewable Energy Act in Germany. But it is, the problem was that these ideas are not coming into the in this act, and so we have to wait a little bit. But on the level of EU, it has started to perform regulations for the or pre-regulations to free or to free the production of hydrogen from renewable electricity from these taxes. So and different
create a different type of, if hydrogen is made from renewable sources and introduced in the gas grid, it doesn't qualify for those taxes.
Yeah,
it's exempt.
Not only for injection for the gas grid, but also for direct use.
Just direct use as well.
It's the same way in both concepts.
And in terms of timeline for those regulation change, when do you think they're coming? It takes time?
Yeah, so it is a question to all of the audience to help us putting information to European officers and parliamentarians to bring information to them that this is a very necessary way to free taxes from hydrogen production.
They need to move fast to help us move this technology in.
To bring up the energy transition in Europe and especially in Europe.
Any question from the floor? Well, I still have a question. Have you seen with you're working really closely with the industry? Have you seen any reluctance from the utilities or the local distribution companies towards such a thing as introducing hydrogen in their grid, or are they really acceptable of this new way or technology in some ways?
Today we are, when I talk about injecting to natural gas grids, we are in a demonstration phase. At different locations we have small plants to produce hydrogen and inject it into natural gas grid. Sometimes hydrogen is used for filling stations for a small number of cars. But the second concept I told to you, this is today more in a research phase, and on that way we try to start up research projects to enlarge, to improve the technologies, and to found some or to erect some large demonstration plants. So to erect demonstration plants not on a small scale but on a larger scale and a more than megawatt scale to bring this technology on an industrial level. So one of these research projects is located in middle Germany near Leipzig-Halle, in this chemical area where also one pipeline is existing. This is called the HYPOS initiative, and this initiative starts to make research and demonstration on the complete chain, starting from the production of electricity from wind and PV, and put it not into the electricity grid, but put it directly into electrolyzers, and then producing hydrogen and storing this hydrogen in underground gas storages and using it in the pipeline in middle Germany. And the end of chain is the usage in fuel cells located at the customer sites, or in fuel cell cars, or in new processes in the chemical industry. So we try to find there early markets to bring this technology
So
under
you're
the
really
people.
focusing on finding industries that already have a hydrogen need
Yes.
to prove out the technology, but not only proving it out, also improving it, because you get to see from the production of a hydrogen from electrolyzing all the way to the end user usage.
Especially to reduce costs, investment and operation costs, to make this technology competitive to the standard fossil technologies. That's the main purpose in that area, to bring this technology into the market and beneficiary into the market.
So a lot of effort put towards bringing the cost down by having those demonstration projects. And my last question to you will be, DBI Gas is involved in the Inifield project. Can you tell us what your involvement is?
Yeah, the Inifield project is a little bit upside from supply concepts for hydrogen. Inifield project is a demonstration project for stationary fuel cell systems all over Europe, and DBI is providing the monitoring systems and scientific monitoring for all these fuel cells, which are located all over Europe.
And this will be ongoing for?
This is ongoing last year, and meanwhile I think about 200 fuel cell systems are
being
working
deployed
in Europe, and from these I think deeply monitored we have about 50 systems, and these informations we take over and bring it to customers and also to the producers of the fuel cells.
And I don't know if you can actually share that with us, but is the initial data looking good?
The initial data is looking very good, but if you ask the people from the EBZ, not far from here, they say, oh, the selling of these systems goes very, very hard because there is not enough support from government to introduce such systems, which are a little bit more expensive than standard gas technology. Yeah.
Well, to everyone in the audience, as well as to you, Dr. Krause, I want to thank you for your time. That was a great interview. If you have more questions for him, you're welcome to go see him to his booth, which is located at B44, which is down this aisle all the way back. And I'm sure he'll stick around right after to talk to you as well. So thanks again for your time.
Thank you too. Bye-bye.
Bye-bye. And stay with us. Right next, we'll take a little break of about 10 minutes, and we'll be back at 3:40 with Decmex Corporation to discuss about expanding technology for batteries and fuel cell. Thank you for your time, everybody. Enjoy your afternoon.